All right, so now we're going to go ahead and talk about a more advanced form of completing the square. This is important for quadratic functions, and I feel like since we've already just gone through the basic form of completing the square, we should go ahead and do the more advanced version of this. So if you recall, we're trying to convert something in the form ax squared plus bx plus c into a times x minus h squared plus k. Now, to do this appropriately, what we can do is actually multiply this out and work backwards from this form in order to get this form right here. So let's go ahead and let's multiply this out. So this is x minus h times x minus h plus k. A times x squared, so I have x times minus h plus minus h times x, so that's minus 2hx. Minus h times minus h is plus h squared plus k. Okay, now we can multiply this out. So this is ax squared minus 2ahx plus ah squared plus k. All right, now what we want this to do is we want this to line up with ax squared bx plus c. So our goal is to line this up. So the same strategy as before. All we're doing is we're trying to write this in a new form where instead of thinking of things in terms of a, b, and c, we're now trying to figure out the a, the h, and the k. Now if we line this up, ax squared is equal to ax squared, so in fact the use of a in both these forms is exactly the same. It gives us the same parameter. The next thing we need to do is we need to find the h in terms of b. And if you line these two bits up, you get negative 2ah is equal to b. Now, if we're given a, b, and c, we want to find h. So the way to do that is we divide both sides by negative 2a, and we get h is negative b over 2a. Okay? And that'll give us the first form. So this is actually the formula for the x-coordinate of the vertex of a quadratic. Now, if we look what's left over, we have that a h squared plus k is equal to c. And if we want to solve for the k is equal to c minus a h squared. And if we go ahead and plug in this h here, we get k is equal to c minus a times negative b over 2a squared. And that's equal to c. I get negative b squared, so that's, sorry, there's a negative here and then negative b squared. I have 2a squared, that's going to be 4a times 4a squared times a is going to give me 4a. And so that in fact gives me the k right there. All right, so those are the two bits of information. So if I were to convert this into this form right here, I would need to go ahead and find this h, find this k, and do it like this. All right, so we solved for the h, we solved for the k, and we did that by working backwards from here and getting back to here. Now, how does this work going forwards? Well, if we take ax squared plus bx plus c, what we're going to do is we're going to take these first two terms and we're going to factor out an a. So that'll give us something of the form ax squared plus b over a x plus c. Okay? So what we've done in this case is we've multiplied out an a just from the x terms. We're going to leave the c by itself. It'll be fine. And if you're not sure why this step works, just work backwards. If we multiply this out, we get ax squared, that's fine, and then a times b over ax. So the a's will cancel and I'll be left with bx. Now just as before, we're going to add and subtract the coefficient of x halved and then squared. So if we look at this, this is going to be half, that's b over 2a, and then we're going to square it. And if we do that, we get b squared over 4a squared. And we're going to do what we did before. We're going to add and subtract it. So we're going to add b squared over 4a squared and subtract b squared over 4a squared. Now, if you recall from the circle problem, we left the plus with this part and we got rid of this negative part by moving it to the other side. We're going to want to do the same thing, but if you notice, the a multiplies everything in here, including this b squared minus 4a squared. So what we're going to do is we're going to distribute this part and this part out. So you get a times x squared plus b over ax plus b squared over 4a squared. So that's the first bit that we left in there. And we're going to take this negative b squared over 4a squared, multiply it by a, and move it out. And if we do that, we'll just move it to the end. We get minus b squared over 4a, because one of the a's cancels out. And if we look at this, this is exactly what we expected our k to be, so that's correct. Now, if we go ahead and look at this part, we can factor this. This is going to be equal to a times x plus b over 2a squared. And then we still have this. With the choice of halving it and squaring it makes it naturally come to this point, because if I multiply this out, it's going to give me x squared and then plus b over 2ax plus b over 2ax. So b over 2a plus b over 2a is just b over a times x. And then if we square this, we get b squared over 4a squared. Now, if we look at this, this doesn't quite look right. We have a negative here and we have a positive here, but if you notice, it should be x minus h. So we're minusing a negative. So if we wanted to write this in slightly clearer form, this would be x minus negative b over 2a whole quantity squared plus c minus b over 4a squared. So we just completed the square for a general quadratic from this form to this form. Now, one of the useful applications of completing the square is actually the quadratic formula. This is a method by which we can find solutions to the equation ax squared plus bx plus c is equal to 0. So if you've seen the formula but not necessarily seen where it comes from, here's how we find it. So if you recall, we took this form and we rewrote it in this form. Now, on initial inspection, this looks more complicated, but that's not so bad. In this case, this form is actually easier to solve for. What we're going to do is we're going to solve for x. Now, how do we solve for x? Well, if we look at this, we have an x inside here, and so we need to get it out by itself. So we're going to take this c minus b squared over 4a, and we're going to move it to the right side by subtracting it from both sides. And if we do that, we get a times x minus negative b over 2a whole quantity squared is equal to b squared over 4a minus c. Now, I'm going to need this as a common fraction, so I'm going to go ahead and divide by 4a and multiply by 4a. That doesn't change the quantity, that's just going to make it look nicer. Next, we divide both sides by a, and if we do that, we're just going to go ahead and erase that. We get a squared and a squared. And now we're going to square root this. And if we square root both sides, we get x minus negative b over 2a is equal to, this is where we include the plus or minus, because when you square root something, there are two possible square roots. There is the positive square root and there's the negative square root. And if we look at that, we get square root, combine the fractions, b squared minus 4ac all over 4a squared. Now what I can do is I can add negative b over 2a to both sides, and that'll give me x is equal to b over 2a plus or minus. The square root I'm going to break up over the numerator and the denominator. The numerator is going to be square root of b squared minus 4ac. In the denominator, the square root of 4a squared is exactly 2a. And we can go ahead and combine these fractions with the common denominator. And so if we look at this, the quadratic formula isn't some formula that just fell from the sky. It's a formula that came from this rather complicated but interesting and powerful technique of completing the square. That is, we take a quadratic, we complete the square, and then by solving this equation, we can just use simple algebraic steps, that is, moving stuff from left to right by addition, subtraction, and multiplication, and maybe the trickiest step of all, square rooting things, and generate this quadratic formula, which lets us find all the solutions to the equation ax squared plus bx plus c.